do this. All right, so starting off, new semester, new year, really, okay? Interval notation, that's what we're talking about. We're in this unit of functions, so we're going to be doing a lot of stuff that deals with equations, a lot of different operations, and things like that, okay? So we're going to start with interval notation, and you guys are going to be able to basically use interval notation to write the domain and range of a function. Isn't that right, Michaela? Mm-hmm. Is it, though? I like your nails. Mm-hmm. There we go. All right. So we are going to start off with the very basics, okay? I'm pretty sure at some point in time in your math career you've done interval notation, so I need to refresh your memory before we apply it to domain and range, all right? So you're given an inequality, okay? What inequality is this symbol right here?
X is less than.
It's less than, okay? Y'all remember your inequalities and things like that? What does the line mean underneath?
Less than or equal to.
Less than or equal to. Great. Now, a long time ago, like Algebra 1, maybe even before that, you learned how to graph these types of things on a number line, right? Like for the first one, you would go to 2 and you would go to the left because the inequality is pointing to the left, right? And then at 2, what would actually be there?
An open dot.
It depends if there's a line or not.
It depends if there's a line or not, right? When was it open?
When there's no line.
When there's no line. So like in this case, right? But then when there was a line, it would be what?
Closed.
It would be closed. So in this case, change colors. You'll have an open circle at 2, and then you would have shaded to the left because that's exactly where the arrow was pointing, right? But then if it was equal to, it would be a closed circle, and in this case, it was still pointing to the right. Correct? Yeah? So what we can do is we can take that inequality, we can take that number line drawing, we can actually write this in interval notation, okay? Whenever there's an open circle, or it's just less than or greater than with no line, no equal to, you use a parenthesis, okay? But if it is a closed circle, you will want to use a square bracket. Does it sound familiar? Maybe? No? This might be new to some of you all, okay? So, all right. So again, when we have just without the line, it's going to be parentheses, but with the line, it's going to be a square bracket. And when we represent this, you have to think, if it's pointing to the left, what number is all the way to the left of this number line?
0.
Well, that arrow means it what?
Keeps going.
All the way to what? You're close. Negative infinity, because the negative numbers after this, right? -2, -10, -1,000, -1,000,000, okay? So the number that's to the furthest left is a negative infinity. So all the way to the left is negative infinity, and then this number line, the shading goes all the way to what number on the right? Positive infinity is all the way over here, but the shading doesn't go all the way. It goes all the way to what number? +2, okay? That is like the hardest part of interval notation, recognizing what exactly is your two numbers. Yes?
So it is 2 even though it's an open circle?
It is 2 even though it's an open circle. Now it's not defined at 2, right? So that means we're going to put a parenthesis around 2. Because the parenthesis means it goes all the way to 2, but it's not defined at 2. Okay? If it were defined, we would use a square bracket because it closes it out. It means that it is defined.
Wait, can you show us a square bracket? Oh, you're going to show us that?
Yeah, for the next one. Mm-hmm. Now, again, you use a square bracket if it's defined. Do you guys know what number infinity is? Or negative infinity?
I remember there was a question that we did this.
It
was
9.
9. Oh, yeah.
No, I don't know what class that was.
No,
but
it was this class.
I'm sorry, what?
It was one of the sum of infinity.
Yeah, the sum of infinity and stuff that did not make sense.
Oh, Lord.
Yeah,
Okay.
infinity equals 9. Yeah.
Okay, I know what you're talking about. Okay, not quite for this, okay? But just in sense, like if I asked you, what number is infinity, what would you tell me?
1264.
Not quite.
+1.
It doesn't have a number. It's not defined. You can't define infinity. So remember, with things you cannot define or that are not defined, you put a parenthesis. And no matter what, you always put a parenthesis around infinity because there's no definite number that represents infinity or negative infinity. Okay? All right. So if you look at this one, what number is the furthest to the left?
Yeah, negative infinity.
Negative infinity. And it goes all the way to what number? Positive 2. Okay? You are going to have a bracket around 2 because it is defined. It is equal to 2. Brackets, or sometimes you hear me say square bracket. Okay? That means that 2 is defined. What goes around negative infinity?
Parentheses.
A parenthesis. Okay? This is called interval notation. Raise your hand if you've seen this before. Really? Okay.
I remember the number line and like the sentence.
So, okay, any part of this that was familiar, the number line, you guys remember doing that, right? Well, then that's perfect. Use that connection because if you're able to visually see, you're like, okay, what number is the furthest left? What number is the furthest right? Because those are the numbers that go in your interval. Okay? Let's look at this one. X is greater than 2. I go to 2 and I'm putting a what?
An open circle.
An open circle, and I'm shading what way?
To the right.
I'm shading to the right. So when I write this in interval notation, I gotta say, okay, so to represent the actual part of this number line that was shaded and everything, what's the number that's to the left? 2. Yes, 1, 0, and negative 1 are also to the left, but those are not involved in this. What's the number to the right?
Positive infinity.
Positive infinity.
Oh, you're right. Okay.
Okay?
They have parentheses, right?
They have parentheses around both of them or just one of them?
Both.
Both, because it's an open circle at 2, and infinity always has a parenthesis. How would I graph this one on the number line? X is greater than or equal to 2.
Close circle at 2.
Close circle on 2
To the right.
and to the right. Which means that when I write this in interval notation, what's the number that's going to be on the left side?
The 2.
The 2. What number is going to be on the right side? Infinity. What's going to go around the 2?
Bracket.
Square bracket and around, excuse me, and around the infinity? Parenthesis. So far, so good? Okay. And you can always use the visual to help you. Some of you guys are probably like, well, I can do this even without the visual, and that's great. Okay? That's great. But I'm doing the visual for everyone, just for those who might not be able to. Now this one, this is a 2-parter. Okay? We need to graph both pieces, and then we'll look at the interval notation. Okay? How do I graph this part right here?
2 open circle.
2 open circle
To the left.
to the left. How do I do this part?
6 open circles to the right.
6 open circle to the right. Wonderful. Now I have 2 things on my number line, which means I'm going to have 2 intervals. Question?
Do we have to do like a line like that?
No, I just do it so you guys can visually see it. Yeah, I do mine with a squiggle like that so you guys can visually see it. All right? So, how do I represent this light pink part in interval notation? What's the number that's furthest to the left? Negative infinity. And it goes all the way to what number? 2.
Oh.
That part represents the light pink part, the part that's on the left side. What goes around the negative infinity?
Parentheses.
What goes around the 2?
Parentheses.
How do I represent the right part?
6 infinity.
6 to infinity. What goes around the 6?
Parentheses.
What goes around the infinity? So far, so good. Now, we're not done with this one. Because we have 2 intervals and they are connected into the same problem, you need a connector to connect the 2 intervals, okay? And what you use is you use the union symbol. This is the same union symbol that's used in set notation with Venn diagrams. Do y'all remember Venn diagrams? The 2 bubbles? Union meant everything in those 2. Nope, over here. Cool. All right. But that's the same union We'll visit that at the end of the year. Okay? Whenever you have multiple intervals, you need to connect them with that symbol. Okay?
So that's like bringing reading into math or something?
We brought reading in when we brought in variables. Okay? Once we brought in X, we brought in reading.
So like you just have to put the U and then you're done with the problem.
And then you're done. And if you don't have the U, you're not done. It's not completely correct. Okay? So you have to do this. So for multiple intervals, you put the union. For multiple intervals, you put the union. Okay? Let's look at the next one. How do I graph this part?
Close circle at 2 to the left.
Close circle at 2
Oh, wrong problem.
to the left. How do I do this part?
Close circle to 6.
Close circle at 6 to the right. So I need to do my 2 interval notations for each colored part. Who thinks they have the light blue one? Haley.
I did negative infinity. There's the 2. And then it's parentheses and then bracket.
Parenthesis and then bracket. Awesome. Who can do the tan part? Bree.
Positive 6 and infinity, and then a bracket around 6 and parentheses infinity.
Perfect. And then what do we need to connect them?
The union.
The union. And that's it. Good stuff. So far, so good?
Yeah.
Now I'm showing you like one of each type. Also, you can mix and match square brackets with parentheses. It just depends on the inequality itself, okay? Let's look at this one. These two are called compound inequalities. It's basically saying that x is in between 2 and 6. X is in between 2 and 6. So your shading needs to be in between 2 and 6. Okay? What do I need it to?
Open chat.
Open circle. What I need is 6.
Open circle.
And I shade in between because that's where X is. It's in between. So then to write the interval to represent this, it'd be 2
And then 6.
and then 6. And I need what around?
Brackets. I meant parentheses.
Parentheses. Around both.
Oh, okay.
It's pretty simple.
What about this one? What do I need it to?
Close circle.
What do I need is 6.
Close circle.
And I'm shading
In between.
in between
And then 2 and 6 and brackets.
2 and 6 and then the
Bracket.
brackets. And that's how you use your number line to write interval notation. Okay? That's how you use the number line to write an interval notation. Questions? Taking this up a notch, okay? Gonna take you back to, again, your Algebra 1 days of solving inequalities, okay? Of solving inequalities. If you look at this, solving inequalities is just like solving an equation. How do you solve an equation?
You solved it.
How? Like what is your overall goal when you are solving an equation?
Get everything on one side.
Get the variable by itself by getting everything else to one side. It's the same thing with inequalities, right? So if I look at the very first one, number 1.
Gonna subtract 2.
Okay, well what I can do is I can subtract 2 from both sides. So that gives me a 5x is less than or equal to 7x. What? Negative 10. And then?
Subtract 7.
You want to subtract 7. Doing it this way, I want to subtract 7. Remember, I want my variables on one side, everything else on the other side. What's 5 minus 7?
2. Negative 2x.
Okay. Almost done. Last thing I need to do to get x by itself is divide by negative 2. And who remembers that when you divide by a negative, true, you do get a positive number,
Flip the sign.
but you flip the sign.
Oh, I forgot.
So you have x is actually greater than or equal to, what's negative 10 divided by negative 2? 5. There you go.
That's pretty nifty.
Anytime you divide by a negative, you can't forget you got to flip the sign. And now what we can do is we can actually take that answer and write it in interval notation. And you guys showed me that you guys can do this. So write this answer in interval notation. So x is greater than or equal to 5. Sonny, how do I write that in interval notation?
Bracket 5,
Infinity? Parenthesis. Very good. Okay? So my answer was x was greater than 5. Writing in interval notation would be bracket 5, comma, infinity, parenthesis. Good stuff. Okay? I want you guys to do number 2, aka number 11 here, on your own. Write the answer in interval notation. All right. Rachel, can you solve this for me, please?
Yes, I can.
Okay.
Okay. So, you're going to subtract 9 first
Mm-hmm.
on both sides, which would make a negative 4W, and then you know the sign. And then negative 3. And then you're going to divide by negative 4 on both sides. And so that'd be W, and then you have to flip the sign. Yeah, like that. And then it'll be the fraction.
Did you leave it as negative 3 over negative 4?
I did, I messed that up, because you're supposed to change that to not, like the opposite.
Right.
But, so then you're writing it, and it'd be, wouldn't that mess up how I wrote the interval? Because I wrote it as negative.
It shouldn't change the interval. It might just change that number.
You just erase the negative.
Yeah, just erase the negatives.
Is that right?
Yeah, you would just take the negative out.
Okay. So, but that's still negative.
Yeah.
Negative infinity,
Mm-hmm.
with the parentheses in front of it, and then comma, and then the, 3 over 4. With the,
Oh, right.
square, what is that? Bracket, sorry.
Yep.
Thank you.
Wow.
Awesome.
I didn't flip the
You can
sign.
just call it a square.
Yes, anytime you divide by negative, you gotta remember to flip the sign.
Yeah.
Okay, make a note of that. Make a note if you need to. All right? So far, so good? Now this one we'll do together, because I don't know if y'all remember how to do compound inequalities. Okay? Compound inequalities are actually very simple, even though they might look complex. Okay? Because I know one thing. Can you guys solve this?
Yeah.
Sure.
Thomas, don't give me that. Are you guys able to solve this?
Yeah.
Okay. So then whatever you do to solve those two individually, you just end up doing it together, right? So if I cover up that 11 and I just work with just the left side, what would be the first thing I would do?
Add 7.
Add 7. And if I were to cover up this part, what would you do? Add 7. Okay?
Okay.
So basically you're just doing the steps to both sides. Okay? What's negative 2 plus 7?
5.
5. Then this will be less than. These cancel out, so then I'll have 5b on the inside. Less than or equal to, what's 11 plus 7? 18. Then, divide by 5. Okay, I would divide by 5 for everything. What's 5 divided by 5? 1. Less than b, because I'm not dividing by a negative, so I didn't switch my signs. Less than or equal to, does that reduce? Huh? Oh, is that a decimal? Oh, no. I mean, if you write as a decimal, that's fine. The decimal better be correct, and it better be 3 significant figures. I know that. Mm-hmm. Let's leave it as a fraction.
Okay, so
Wait, why did we divide? Because I was still on the last step.
Yeah. So it's pretty much like we had this part here. And so, we would divide both sides by 5 to get the variable itself. And then we also had this part here. And then we would divide by 5
Okay.
to get by itself.
I'm just seeing how the flip
Your
goes.
companion.
Oh, things going good? All right, so now we gotta write as an interval notation. It's a compound, just like the last ones were on your pink one. How do I write this?
Oh, it would be
It'd be 1 with the what? A parenthesis, comma, 18 over 5 with a
Bracket.
bracket. So it's in between 1 and 18 over 5. So that would look like this on the number line. 1, 18 over 5, open circle, closed circle, everything in between. That's what it would look like.
Before I end up on Pluto, how come when you divide 5 and 5, the 1 goes in front and not stand in the center?
Because that
Wait,
cancels
what?
out.
Because it cancels out. 5 divided by 5. It turns into a 1b, essentially.
The one is from the 5 divided by 5, not the 5 v.
I wrote that wrong. Let me correct that. Now it is correct.
Questions?
So just a simpler way to.
Your hand, sir.
Oh, my bad.
Yeah, there's a couple of y'all. Every time I turn around, my blood pressure rises, which means I start getting high and I start sweating. Then I gotta turn the air on, then it gets cold, and then my goes
It
down.
does get hot in this classroom. Yeah.
It does, but it gets even hotter when I turn around and I see hands on faces. So far, so good?
I just had a question. So like a simpler way to think about it is like.
No,
No, I'm just.
Should I pause the video?
When you get the simpler way, right?
Uh-huh. Everything together.
Yep. Then you just basically you get like you take out the middle and then you put the comma.
Yep. Pretty much the middle turns into the comma. The variable turns into the comma.
Cool.
All right. So now, how do we feel about writing interval notation?
Yeah.
I prefer
now
not
we're
to
gonna
do
do
it,
something
but
that has
I
nothing.
have to.
No, it is still. Wait, remember, I said we're going to take the concept of interval notation, had to make sure you guys know how to use it, and now we're actually going to apply it to finding the domain and range of functions. And the same concept applies. Think of the number line. How far left do we go? How far right do we go? Okay? Let's start here. We're going to be given a whole bunch of functions, a whole bunch of graphs, and we're going to write the domain and ranges for each of the graph. Now, before we go into what they actually are, I need to make sure everybody knows what domain and range is. What is domain?
The domain is the
X value.
It's the x values of a function. So domain is the x values, so that means range has to be what? The y values. And when I say x values, that means how far left on the x-axis does this graph go? How far right on the x-axis does this go? When you're thinking about domain and interval notation. Range is going to be the opposite because range is your y's. Instead of going left to right, we're going to go bottom, because that's where the negatives are, to top. How low does it go? How high does it go? Okay? So, if we look here, this one's already done for you, okay? Because I didn't want to throw anybody off on the very first one. This is a horizontal line that has an arrow, which means it keeps what? Going. Which means that all those x values on this line, they're going to go all the way to what? Negative infinity. So negative infinity is my furthest to the left, and then positive infinity is my furthest to the right that it goes. And so, just like before, we put parentheses around infinities, and that's why our domain is negative infinity to infinity. Does everybody understand that? Okay.
That sounds like something that what's the guy from Toy Story? The little spaceship and then
What?
Oh, Buzz. Oh, to
Lightyear.
infinity.
Buzz.
Oh my gosh.
To infinity.
That actually made sense.
For once, that's
Thank you for the name
Hey.
of Buzz.
Let's look at the range. Now, it might be kind of hard to see this one, but what's the lowest y value that this line
3.
goes? 3. What's the highest that it goes?
3.
3. So if the lowest that it goes is 3 and the highest that it goes is 3, it's just going to be 3 to 3. Because it doesn't go anywhere else. It's
'Cause it's
just
just
at
flat.
3. It's just a horizontal line.
Would that be square brackets or parentheses?
Good question. Square parenthesis.
Square.
Oh wait, I mean square.
It is actually square. Because isn't 3 defined at every single one of these points that I'm plotting on this line?
Yeah.
So if it's defined, you put the square brackets. Let's look at this one. F of x equals 3x minus 4. It is a linear equation. And since it's a line, that means lines go on and on and on forever.
So it's gonna be infinity?
So what do you mean infinity?
Well, negative infinity and positive.
It is. Because it's a line and it goes on and on forever, it's going to continue to increase and going to continue. The furthest left it goes is negative infinity. The furthest right it goes is positive infinity. That is your domain. What about its range? What's the lowest that it goes?
Infinity. Negative infinity.
Negative infinity. What's the highest that it goes?
Infinity.
Positive infinity. There's our range.
Oh my gosh, I keep writing 8s as infinities. It's really bothering me.
How is the domain then?
Yeah, we
I thought the domain was from left to right, right?
It is left to right. And if you think about it, if I were to keep on going, my slope is 3. So that means I'm going to go up 3, 1, 2, 3, over 1. Up 3 over 1. No matter what, I'm always going over 1. And granted, it might take forever to get all the way to infinity. It's still going to continue to go over 1 to the right every time.
And it's an
Literally,
arrow.
it'll take forever.
And it has the arrow, which lets you know it keeps on going. If there was a point, that means it stops. And you figure, okay, well, how far does it go before it stops? Okay? So far, so good? All right. Let's look at another one. Let's look at number 13, because 13 is in your notes. Okay? This is an example of the absolute value equation, absolute value of x. How far left does this go?
Negative.
Negative 2.
Negative
Negative
infinity.
infinity.
Negative infinity. How far right does it go?
Positive infinity.
Positive infinity. That is my domain. Remember, domain is how far to the left, how far to the right. What about the range? What's the lowest it goes?
0.
What's the highest it goes?
Infinity.
And remember, if it has arrows, infinity is going to be in there somewhere. What do I, of course I know I need parentheses around infinity, but what do I need around 0?
Square brackets.
And it is a square bracket because there's that point there.
It's defined.
It's defined. And also, even if it doesn't have the point there, let's just say it was just the regular V without that actual point there. It's still defined. The only time it's not going to be defined is if there's an open circle on the graph. Or an asymptote. But we're going to get to that later.
Yay.
On your desk, I want you guys to do this one. On your desk, I want you to do this one. Because remember, absolute value turns everything to positive. So if you plug in a negative x value, no matter what, your y value is always going to be positive. So that's why it looks like a V. All right, Thomas, what's my domain?
Negative infinity, infinity, and beyond.
Very good. And Shalyn, what's my range?
Bracket -2,
Good stuff. Awesome. Back to your notes. Let's look at number 7 on yours. 7 and 8. Flashback to memory lane and good old quadratics. Good old quadratics. The arrows means it's going to continue to go. And if you remember anything about quadratics, they get wider as they go on and on forever. What's the domain going to be for this one? Negative infinity to positive infinity with the parenthesis. Okay? Because again, if you remember the pattern, it was down 1 over 1, down 3 over 1, down 5 over 1, down 7 over 1, down 9 over 1. No matter what, it's still going over 1.
Is it ever gonna be something else?
Mm-hmm.
Okay.
Oh, yeah.
Oh, yeah.
I knew that
Oh, yeah.
Okay.
What about the range? What's the lowest that it goes?
Negative infinity.
Negative infinity, so I need a parenthesis around that. What's the highest it goes?
4 bracket.
4 with a
Bracket.
bracket.
Miss Anderson, how long does it take you to prepare each one of these lessons?
Too long. It really does.
Is this something like you just use year after year?
Once it's created, but if it's not created,
My mom would have to
Like
stay
this?
after school for hours.
I
It
forgot.
was like
I mean, I'm already staying after school for hours, so yeah, but yeah.
she used to stay until 8 every day, and she would be on the weekends. 'Cause she
Mhm.
like
I'm about to say, teachers, see, we're the only profession where you take work home with you.
her retirement's pretty good though. So
I
I mean,
can't
like, you
wait.
have that to look forward to.
30 something years later. You're
Well,
right.
yeah, she
Well, actually,
Got
I'm
30
down to 20. I could retire. I could retire in 20 years,
You can
but
retire in 20 years.
you know the way the government is going, I'm gonna need to stay in teaching for about 40. All right, here we go. Domain. What's the furthest left it goes?
0. Or,
0. You're right.
yeah.
0.
I was just double checking myself.
Goes all the way to infinity. There's that arrow. That means it's going to be an infinity somewhere. Anytime you see an arrow, it's going to be an infinity somewhere. Okay? What do I need around the 0?
Bracket.
Bracket,
Parentheses.
parenthesis. This is an example of the square root function, radical functions. Okay, all those ones that we did at the very beginning of the year. This is what those graphs look like. Okay? The range. What's the lowest it goes?
0.
And the highest?
Infinity.
Infinity. Because it is going to keep
Oh.
increasing. What do I need around 0? Bracket. Around infinity?
Parentheses.
Very good. Let's practice some more. On your desk. Okay. Something I need you guys to be aware of is that if you take a look, horizontal lines, linear equations, absolute value equations, quadratic equations, their domains were always negative infinity to infinity. So you didn't have to see the graph to know that. So if I give you a function and it's a quadratic function, you're going to know automatically what the domain is. It's going to be negative infinity to infinity. If I give you a linear equation, you should know that its domain is negative infinity to infinity. Okay? But there are going to be some that aren't going to be negative infinity to infinity. We did this one right here, the square root functions. That's one of those. They will not be negative infinity to infinity. Okay? Another type is when you have a fraction and a variable in your fraction. Okay? So everyone should be at the ones where it says finding the domain of a function. All right? Are we there? Remember, domain is x. There are going to be 2 stipulations where the domain is not going to be negative infinity to infinity. The first one, if you have a denominator and you have a variable in your denominator, okay? What number can we not divide by? Say again? 0. Because anything divided by 0 always gives us an error message in the calculator, right? It's undefined there, okay? So, the denominator can never equal 0. So if you have a fraction, a function that's a fraction, you have to basically take the denominator and set it equal to 0. The domain of these types of functions is going to be every real number that there is except the number that makes the denominator 0. Okay? So if you look at this one, it says 1 applies. Denominator cannot equal 0. Because if it was 0, it would be 1 over 0, and that would be undefined, right? So, real quick, on a number line, this is what it would look like. There would be an open circle at 0, but it would be defined everywhere else. Does everyone see that?
So, like, would it be infinite, or how could it be defined?
How can it not be defined?
How could it be defined?
Well, if I plug in any number for x, like if I plug in 3, don't I get an answer back?
You should.
And I do. If I plug in 3 for x, what's going to be my y value? This is for anybody. If I plug in 3 for x, what do I get?
1/3.
1/3. That's my y value. If I plug in -5 in for x, what's going to be my y value?
1/5.
-1/5. But if I plug in 0 for my x,
0.
it doesn't work. It's going to be undefined because you can't divide by 0. So every other number but 0 works. This is what the number line would look like for that.
So on that one, you would do 2 and you would put the U in the middle?
Exactly. So for the domain of this one, you would create 2. How do I represent this part here? Negative infinity all the way to 0. And I need what around 0? A parenthesis. How would I represent this part?
Parentheses 0, comma, infinity, parentheses.
And I need a union to connect them. Okay? So this right here basically says that every number except 0, because there's a parenthesis there, it's not defined at 0, but every other number works. Okay? That's your first rule. That's going to be a situation where it's not going to be all real numbers, if there is a variable in your denominator. Let's look at this one. Okay? It's already factored out for us. So we have to figure out what numbers are going to make this 0. So we set x minus 1 equal to 0, x plus 3 equal to 0. And I solved this. What's x going to be here? It's going to be what? 1. What about here?
-3.
-3. So if I plug in 1, that's going to give me 0 in the denominator. If I plug in -3, that's going to give me 0 in the denominator. So every other number except -3 and +1 work. On a number line, this is what it looks like. I have -3, I have 1. I have an open circle at both of them, and then everything else is shaded. It's every other number except -3 and 1. How many intervals am I going to have for this one?
Did you end up with 3?
You end up with 3. You need an interval to represent this part here. I need an interval to represent this part. And I need an interval to represent this part.
She's like -4 and -2, right?
What do I use to represent this way? It'd be -infinity all the way to
-3.
-3, and I need a parenthesis. How do I represent the middle part?
-3, comma, 1.
-3 to 1, parentheses around both, and then this part?
1, parentheses around 1, to infinity.
To infinity. And what do I need between each one of these? Unions. These are the ones that suck the most. And especially when you're writing them in interval notation. But for rule number 1, you just have to recognize what makes the denominator 0, and it's everything but that number. I'm doing the number line here to help you guys visually see it. I think some of you guys actually do okay if you can visually see it. That's why I'm still doing it. If you get it without me doing it, then that's great. Questions? The second rule is the radical. You remember the one that we did, the square root of x? The domain was from 0 to infinity. This is another stipulation. You cannot take the square root of what types of numbers?
Negative numbers.
Thank you. Negative numbers. You cannot take the square root of negative numbers. So if you have a radical, then whatever's underneath the radical, you have to set that greater than or equal to 0. Okay? In this particular case, I have a radical, and on top of that is in the denominator. What number cannot be in the denominator? A negative, nor a 0. So in this case, we have to take what's underneath the radical and set it greater than 0, because I can't take the square root of a negative number, and I can't divide by 0. That's why it's not equal to 0. And I solved this. How do I solve this?
Add 2. And
Minus
then
2.
divide by
Minus 2.
Oh, yeah, that.
So I have negative x is greater than negative 2, and then,
Divide -1. Flip sign.
and I flip the sign. So it's going to be x is less than 2. That right there is my domain for this particular function. How do I write that in interval notation?
It'd be 2 to the.
Infinity,
Yeah, you
comma
need
2.
to write that out. Okay, wait.
We got
I was
a
trying to
2.
think of
Open
it.
circle or closed circle?
Open.
Open.
So
Which way?
2, I mean, negative.
To the left.
To the left.
So it would be like a
negative
Negative
parenthesis.
infinity, comma 2.
And then parentheses.
There we go.
Okay, I just needed a
God.
picture.
All right. Just let me know. We'll do it. Okay? If there is a fraction and the variable is in the denominator, you set the denominator equal to 0. The domain is going to be every other number except the number that makes the denominator 0. If there's a radical in the denominator, you set whatever's underneath the radical greater than 0. If it's just a regular radical, you set that greater than or equal to 0. Okay? Let's look at some. Okay? Let's look at this next one. It's on your paper, right?
Yes.
Okay. Is this going to be that first stipulation about the denominator or the second stipulation about the radical?
The denominator.
The denominator. I have to set the denominator equal to 0. Because the domain is going to be every other number except the number that makes the denominator 0. How do I solve this?
That's 1.
Add 1. So x equals 1. The domain is every other number except 1. 1 makes this undefined. So it's going to be everything but 1. How do I represent that in interval notation?
Negative infinity.
Negative infinity to 1, right?
Mm-hmm.
And then
And then,
parentheses on both.
yeah, 1, comma,
And the U. And
yeah.
then parentheses 1 to positive infinity.
Yeah.
I was piecing it together. I heard you all. And if you notice, I try to write it so that, like, this interval represents the left side, this interval represents the right side, so you can see it. Let's look at 18. Is this stipulation 1 or stipulation 2? It's 1 because I have a denominator, right? I have to set both of those equal to 0 because there's 2 of them there. X equals what? X equals? So it's going to be everything but -2 and +1. Everything but those.
So it'd be negative infinity
Negative infinity
to negative 2.
to -2.
And then parentheses around the negative infinity and then the negative 2.
Very good. So that represents this part right here.
And then the U
In the U
negative 2 to 1.
with the parentheses, that represents the middle part
And then the 1 to infinity.
with parentheses and the U. Does everybody see that?
It's a lot easier.
With the number line?
Yeah.
Okay. Just draw it. It's totally fine. Talk to me.
Hi.
I remember kind of struggling with this in Algebra 1, but it seems a lot easier.
It usually is the second time around. Yes. Or you just stretching?
Will these always be open circles?
For the denominator ones, yes. Because it cannot equal the number that's going to make the denominator 0. Okay? Let's look at the last one. This is stipulation 1 or 2?
2.
It's 2
1 and 2.
and 1. Because isn't that radical in the denominator? Whenever the radical is in the denominator, you take whatever's underneath the radical and set it greater than 0. And then you have to solve that. How do I solve it? Subtract 3. Then I have to do the number line for this one. Open circle or closed circle? Shading left or right? How do I represent that in interval notation?
-3, infinity. Parentheses.
Wait, why wouldn't that one be a bracket?
Because since the radical is in the denominator, it can never equal 0.
Okay.
So if I were to plug in -3, that would give me 0 in the denominator, and I can't have that. Savannah, then Bugs.
The little top part, the 2x plus 3
It has no effect on it.
So y'all just math.
All right.